Welcome back, Physics 30. So this is the next part. We talked about friction forces, kinetic friction, static friction. Kinetic friction, meaning that FF is equal to mu K multiplied by Fn, and then static friction depends upon the applied force. If there's no applied force, there is no friction until it reaches a maximum amount. And we'll take a look at these scenarios with this next example if you look over here. So here we have a 10 kg mystery box. So here it is right here. I'm just going to redraw it just so it looks like how it usually looks when we draw them. So we have Fg pulling downwards, Fn pulling upwards, and we'll likely have an applied force working in this way and a friction force working that way. But of course we can see here that we don't have any angled forces, so Fn and Fg will be equal and opposite in magnitude. So it's a 10 kg mystery box. So just like when we've done this, it seems like we always talk about a 10 kg mystery box, but if we look at this, Fg is equal to mg, of course. So Fg is equal to 10 kgs multiplied by negative 9.80. So the force due to gravity will be negative 98 newtons. And of course, if we analyze this situation vertically, the total net force vertically, the only thing we have operating vertically is Fn and Fg. And of course, vertically, the object isn't going to accelerate upwards or downwards, so the net force is going to be 0. So of course, when solving for Fn, plus 98 plus 98, Fn is equal to plus 98 newtons. Okay, so that's kind of the preamble that we're going to look at here. If we look at the actual question, so it's pulled at rest on a horizontal floor. The coefficient of static friction, so the friction that I'm going to encounter when I try to attempt to move it, and the coefficient of kinetic friction is that. So notice that static friction, the coefficient, is bigger than kinetic friction. And that makes sense because it's going to take more force to get it moving than it is to keep it moving. Because again, those surfaces interlock with each other when it's at rest. But once it's moving, those pieces don't interlock as easy. So here we're going to simply determine the friction force in all of these scenarios. So if I'm not pushing it at all, if I'm pushing it 10 newtons forward, 20 newtons forward, 30, 40, etc. Okay, so first of all, let's take a look at, so we have these equations here, right? So we had, let's call this, so let's look at static friction. So the force of friction is equal to mu s multiplied by Fn. So that's simply what we got from before there on the other sheet that we had. Looking at that, and then kinetic. Of course, kinetic, as you'll see later on, I kind of distinguish between the two frictions by putting a little subscript C here, or S here, and a K here, but I'll just leave that out for now. Now, of course, this is going to be mu K multiplied by Fn. Now, technically here, instead of putting this equal sign, what I should be doing when solving for FF is I should just simply refer to this as less than or equal to, because it's going to be less than or equal to that maximum value. So over here, my static coefficient of friction is 0.4. My normal force is 98. So that's going to give me 39 newtons. And of course that's less than or equal to, or less than or equal to. So the static friction force can be anything from 0 up into 39. Kinetic friction, though, once it's moving, it will be equal to this number. So coefficient of kinetic friction is 0.3 multiplied by 98, and that's 29. Okay, so those are my friction forces starting and moving. Okay, so if I look at A is if my applied force is 0, well, object doesn't move. It's kind of silly to do that one, but hey, that's what it's going to be. B, when FA is equal to 10 newtons forward, I'm going to put a pause in front of there, indicating that's moving positive to the right. Now, the thing isn't moving yet. I'm pushing with 10. Notice, yeah, see, I can have any value from 0 to 39. Therefore, again, object does not move, since FF will be -10. So notice, it can be a number in between 0 and 39. If I'm pushing with 10, it's pushing against me with 10. Maybe I'll fit one more on this page and we'll move to the next page because I think we have room there. If FA is 20 newtons, again, the maximum friction that I'm going to be working against is 39. So again, object does not move, since FF is going to be -20. It's working against me. So again, my maximum force is that. I haven't reached it yet. Okay, if we turn to the next page, we'll continue this on the next page. So if we look here, we had so 10 newtons, 20 newtons. Now let's do 38. So 38, let's simply move it up here. D, FA is equal to plus 38 newtons. And again, object does not move, since FF is equal to -38. So again, I haven't reached that maximum number yet of 39. So 38 newtons. So the next one, E, what happens if I pull it with 40? So let's take a look here. EFA is equal to plus 40. Now, it will start to move because I've overcome that maximum amount of 39. If I was pushing with 39, it still wouldn't move because my maximum 39 is working against me. But as soon as I push a little bit above, object will move, and then be subjected to kinetic friction, because once it starts to move, then kinetic friction takes over. And my kinetic friction that I figured out earlier, is -29. So once it starts moving, then kinetic friction takes over. So less friction is going to be applied to it because it's already moving. It took me a large amount to get it moving, but once it starts moving, I can ease up a little bit and it'll move at constant velocity, or if I'm still pushing it at 40, it will of course begin to accelerate. Okay, so if I look at figuring out, let's just see here, how about we look at this horizontally then, at this part. So if I'm looking at this scenario horizontally, F net is equal to my applied force plus friction force. Now it is going to, if I take a look here, I'm applying 40 and I have -29 working against me. So I will have a net force being exerted here. So F net is going to be equal to 40 minus 29. That's going to give me an overall force of, not sure what I'm doing there, 11 newtons. And of course from there what I could do is figure out the acceleration. How fast is this thing going to accelerate, or how much is the velocity going to change? So 11 It's a 10 kg object. Divide by 10, divide by 10. My acceleration is going to be plus 1.1 meters per second squared. So I'm going to be moving or accelerating. So that's the key thing to look at this. Kinetic friction versus static friction. Static friction is always going to be a larger amount. It's going to take a lot more oomph to get it going than it is to keep it going. Once I've surpassed that static friction barrier, then kinetic friction takes over. All right, we'll see you again in the next video, which will look at the positive and negatives of friction and then go through a couple of more examples.